S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Now we know that the light is traveling in the form of wavefronts or the wavelets. How these wavelets superimpose on each other and how we can represent their resultant amplitude, that is calculated when the wavefronts are adding up or when they are in the we are subtracting these two wavefronts, then what will happen to the light? So myself Narinder Kaur, now let us understand this in the form of interference of light. If you want to study this topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now what is the interference of light over here? So interference of light is basically, that is a phenomena of formation of maximum intensity at some points and minimum intensity at some point. When the two or more waves with same frequency and constant phase difference are superimposed on each other, this phenomena is called as interference. So now what is interference over here? That means, firstly the main condition for interference that the wavelets or the waves which are superimposed on each other, they must have the same frequency. So that is important over here. The frequency of the wavefronts, that must be same, or you can say that same wavelength. The wavelength for these which are superimposed on each other, that will be same. Let us suppose they have the different wavelength. Means when, if this is a one wave and that is a second wave, so we can never add up these two because they are having the different wavelength. We are not able to get their resultant. So in order to get a resultant of the wavelets more than one or two or more waves, first condition is that they must have the same frequency. So same frequency means, then what is the meaning of frequency over here? Frequency means the number of waves which are crossing per second, they must be same. So that is represent the frequency over here. So now we know that when the two waves or the more than two waves, they combine with each other, they superimpose on each other, then their resultant that can be represented or that can be calculated, that is given by the interference of light. Now we know that in the interference of light, the waves, they are superimposed on each other. So due to superposition of the waves, their amplitude or their wavefront, that can be divided. How that can be divided, that will be understood over here. So this is a type of interference. So that depending upon that, the type of interference, that is of two type. One is a division of wavefront, second is a division of amplitude. So first, what is the interference? So that can be understood over here. So interference is basically superposition of waves. And what is the main condition for the waves to be get superimposed? Number one, these waves are of same frequency. Second, they are of same wavelength. So this is the main condition for the two waves to get superimposed on each other or to give the resultant intensity over here. Then the resultant, that can be done. Now next is the interference, that is done by two methods. One is a division of wavefront. Now what is the meaning of wavefront over here? So firstly, what is the wavefront? The coherent sources. What are the coherent sources? The sources which are giving us the light with the same frequency or the wavelength, or in some cases the amplitude, that must be same. So how we can get the coherent sources? Now if this is a source S, now we know that that will spread the light in the form of sphere over here. Now present the two slits in front of this source. Now when the two slits are present over here, we know that from the source the wavelets are travel in the forward direction. The light is given in the form of wavelets or in the form of wavefronts. Then the light here, it is travel in the form of wavefronts over here. Now we know that the light which is coming out from this slit and coming out from this slit, both of them have the same frequency. So this is the first condition, the coherent sources that can be generated. Because when we are taken the light, we have taken the light from the two different sources, they can never be coherent source. So for the interference of light, first condition, that is the sources must be coherent to each other. So what is the condition of coherency? That means from the single source, the coherent source is two or more coherent sources that can be produced by representing or by placing a slit in front of this source. When in front of this source, slits are represented. You can place a slit over here also. Again the wavelengths are travel in this case. So if this is the slit is S1, S2 and S3. These three slits are present over here. Now the wavefronts which are coming out from these slits. So here the wavefront which is coming out from this slit over here and over here. So these wavefronts, they must have same frequency, or you can say that they have the same wavelength. So such type of sources are called coherent source. So this is the first condition, which is an important condition for the interference. The sources must be coherent to each other. Now, so the first one, the coherent sources are obtained by dividing the wavefront. So in this case, the wavefront that can be divided originating from a common source by employing a mirror. You can place a mirror, biprism or the lenses that can be represented in the path of a source. So you can place a mirror, biprism or the lens in the path of the source. So this class of interference that require essentially a point source or a narrow slit source. That means the source which is taken as a primary source, that can be point source or the narrow slit source. The instrument which are used to obtain the interference by division of wavefront are Fresnel biprism, Fresnel mirror or the Lloyd's mirror or the lasers. That means in this case we know that now the wavefront that is divided into different parts. So these are known as a coherent source. That means here the wavefront is divided because a source that is a firstly source that is a combination of different wavefronts, or you can say that the different wavelets, which is also known as secondary wavelengths. Then these secondary wavelets, these are divided. Now you can place here, if this is a source, here you can place a biprism also. When the biprism is placed over here, then this, firstly this prism is known as Fresnel's biprism. Why this is called biprism over here? Because due to biprism, this light source is divided into two parts. When you rotate this one source, instead of one source, you can see here the two sources are present over here. So that means the one light that is separated into two parts. So that's why this source is known as, this is called Fresnel biprism over here. That means the one light that is separated into two parts over here. That means again there comes secondary wavelets from each source. Then on combining these two, these wavelets then again superimpose on each other to give the resultant over here. So there, now if this is a screen over here over which we want to get the result, so these two wavefronts, they will superimpose on each other to give us resultant. Then here the secondary wavelets, which is known as secondary wavelets. Now each point on this source, each and every source, that will act as a source of secondary wavelet. That means this wavefront is again become the source of secondary wavelet. Again that wavelets will produce another wavefront over here. Then each point will represented here, that will give us another wavelet. Then these all wavelets will superimpose on each other on the screen to give us the resultant over here. So in this case, this type of interference is called division by the wavefront, because here wavefront is divided into two parts. So on dividing these into two parts, then after that, this is the one source, it is divided into two parts. That means its amplitude that is get halved over here. In this case, the amplitude that will remain same. So the amplitude that will remain same. So that means the two wavefronts, they are again two wavelets. From single source, we are getting the two wavefront or the two wavelets with the same amplitude, same frequency and same wavelength. Then they will again superimpose on each other to give the resultant over the screen. So this is the interference of how the interference is done by using the division of wavefront. Let us take a short break. So now we understand what is the interference of light and how the interference of light is done by using the division of wavefront. After the break, we will understand the interference by the division of amplitude.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Before going to the break, we have understood what is the interference of light and the interference of light by the division of wavefront. Now we will understand what is the interference of light by the division of amplitude. Now next is the interference of light by the division of amplitude. So as its name indicated, the amplitude of the wavefront that is divided over here. So now the amplitude of the incident beam, we know that that can be divided either by reflection or by the refraction, or you can say that by the transmission. So here the amplitude of the incident beam that can be divided into two parts, either by partial reflection or by the refraction. So in this case, we know that when there comes reflection or the refraction, the two coherent beams that are produced by the division of amplitude, then these beams will travel the different path and then finally brought to combined to each other, we will get the interference pattern. So in this case, the effects resulting from superposition of two beams, they are referred to as the two beam interference, and those resulting from superposition of more than two beams referred to as multiple beam interference. Means when from the reflection or from the refraction we are getting the two beams, so that is called interference by the two beams, and when we are getting the reflection or from reflection we are getting the multiple beams, so that is called interference by the multiple reflections or the multiple interference, that is called multiple beam interference. The interference, for example, the interference in thin films, Newton rings and the Michelson-Morley experiment or the interferometer, these are the examples how the interference that can be done by the division of amplitude. That means in the division of amplitude what will be done? Now if this is the surface over here, we know that here when the light is incident over here, we know that partial reflection or the refraction that can be done. So that means at this point along to the normal, either the light is get reflected or it is get refracted. So this is called reflected light and this is called refracted light, and here this is the incident beam. Now if this is a beam, so that can be represented in the form of wave here. So this is the incident beam. Now there is a reflected beam over here and some part is get reflected over here. Now you can see that here in this case the angle phase frequency that will remain same, but on partial reflection or refraction the amplitude of the beam that is divided over here. That means if this is a y, so that can be represented as a sine omega t. This is a incident beam. Now the reflected beam, the y1 that will be equals to a1 into sine omega t. The refracted beam y2 that will be equals to a2 into sine omega t. That means the amplitude a that is divided into two parts, a1 plus a2. So in this case again then these two waves they will reunite with each other or interfere to each other to give the resultant wave over here. So here the incident beam is divided into two parts. One is the reflected and the refracted. So in this case the amplitude is also get divided. So such type of interference that is called interference by the division of amplitude. That means amplitude is get divided over here. So that is means when we are understanding the reflection or the transmission of the light. So in that case the division of amplitude that is get applied. So the amplitude of the wave that will be get affected over here. Now when there are the multiple surfaces or the multiple light that is get reflected or the reflected. So instead of two sources there are the multiple reflections and the refractions are done. So that is called multiple beam reflection. And if there is a single light which is get reflected or the refracted or the two lights, so that is called two beam interference. And when there are multiple beams are get reflected or refracted, again now these beams that will superimpose on each other to give the interference. So this is called multiple beam interference. Here we will get the resultant one wave, so that is called interference by multiple beam interference. So that will be obtained in this case. So here, so this is called the division of amplitude. Means in this case there are the different phenomena like interference in thin film, Newton ring experiment, that will be understand over here. Then on the basis of amplitude, how the amplitude of the two waves, resultant wave that can be calculated. The interference is again of two type. One is a constructive interference, second one is a destructive interference. That means how we can calculate the resultant intensity of the two waves. So firstly when the two waves superimpose on each other and they are in the same phase, the amplitude of the resultant wave that is equals to sum of the amplitude of the resultant wave. So this is called constructive interference. That means for the constructive interference, now if this is the one wave and this is the second wave, here y1 that is given as a into sine omega t. Now the two waves must have the same phase over here. So this omega t represent the phase that will be same. Now y2, if this is equal to a2 into sine omega t, phase means this must be same. So this must be same for both the waves. They can be of the different amplitude. Now in the constructive interference, the resultant of these two that can be given by sum of their amplitude. Means when these two waves superimpose on each other by applying the principle of superposition, the resultant that is equals to y1 plus y2. Now on adding these two we will get over here now this is a resultant wave. So this implies for the resultant wave their amplitude will be equals to sum of the amplitude of individual waves into phase will be same. So the resultant of these two, that means when they are adding up, when you add up these two, the resultant that will be equals to this one. So that is the resultant wave, means this amplitude that is equals to summation of both the amplitude a1 plus a2. So this is known as the constructive interference. So resultant amplitude, that will be equals to sum of these two. So that is called constructive interference, while the phase of this, that is same as that of, that is a sin omega t, same as that of the individual waves, that is same over here. So this is called constructive interference. Now second is a destructive interference. Now when the two waves superimpose with each other in the opposite phases, means their amplitude is different, they are in the opposite phase to each other, then the amplitude of resultant wave, that is equals to difference in the amplitude of individual wave. So that will give us the minimum intensity. Here we are getting the maximum intensity, here we are getting the minimum intensity of the light, and that is called destructive interference. So destructive interference means, now if this is the one wave, now second, if this is the second wave, if this is, here it is A1, amplitude is A2. Now they are superimposed on each other with the opposite phase. So phase difference between them is 180, because if there is a positive lobe, there comes negative. Again for the negative we are getting here positive lobe. Then their resultant y is equals to, so we will subtract these two. So that will be equals to y1 minus y2. So resultant will be equals to A1 minus A2 into sin omega t. It depends whether the A1 is more than A2 or A2 is more than A2. Now if A2 is more than A1, then we will get here A2 minus A1. So this is a resultant amplitude over here. So that means the resultant, that will be equals to difference in the amplitude of for both, when both the waves are superimposed on each other with the opposite phase. So this is called destructive interference. This is called destructive interference, and the resultant intensity is minimum in this case. So that means if A1 is more than A2, then for the resultant we will get this one. So that means amplitude, that will be minus of this two. So this is the resultant over here. This is the resultant intensity, and which is the minimum of both the waves which are superimposed on each other. So such type of interference is known as destructive interference. So in the destructive interference, the amplitude, that will be minimum. So here that we are getting here minimum intensity of the light. So that is called the destructive interference. So interference, that is of two type, one is constructive and second one is a destructive interference. We understood the type of two type of interference, one is a constructive interference and the destructive interference. How the waves superimpose on each other. This topic in detail, kindly refer this book by S. Chand Publishing. All the topics are given in quite details in the given book. Now the e-book link has been given in the description box. Now if you like the video, kindly like, share and subscribe this video, and also you can press the bell icon for the future notifications.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.